Okay, so we're going to try doing notes at home with Miss V. So just follow along as I go along. I am going to write in pen just so it's easier for you to see. I would prefer that you do your notes in pencil. And let's go ahead and start. If any time you missed something, just hit pause and get written down what I have written down, and then hit play again, okay? All right, so let's talk about horizontal and vertical lines. So we've been talking a lot in class about what the slope of a horizontal line is, okay? So let's think about two of these points. So let's take two of these points on this line, any two. So the coordinates for this point right here are 0, 2, and the coordinates for this point are 4 and 2. And so we know from figuring out delta y over delta x that would give us our slope. So from 2 to 2, we don't go anything at all. We don't go anywhere, right? And then from 0 to 4, we go up 4. Well, 0 divided by anything is 0. So the slope of a horizontal line is always, always, always 0. Think of me standing on the floor in front of you, and I'm not tipping over because it's perfectly flat, okay? Vertical lines, the other way you'll know, when you look at 2 points, you'll know that they're horizontal because both of their y coordinates are the same. So we have 2 and 2, okay? You'll know that that's going to be a horizontal line because both of the y coordinates are the same. Now let's do the same thing for the vertical line. So there's one point. That point's coordinates go over 3 and then 0. So -3, 0. And let's pick any other point, doesn't matter. Let's pick that one. So that'd be -3, +4. Okay? And if I do this time we'll do y2 minus y1 over x2 minus x1. So 4 minus 0 over -3 minus -3. When you have a negative negative, that gives you a positive. So 4 minus 0 is 4, and on the bottom, -3 plus 3 would give you 0. Remember that you cannot divide by 0. That is what we call undefined. Okay. So anytime you have a vertical line, you're going to have a slope that is undefined. Okay? So sometimes we're not given a picture, like we were up there. You're just given points. So then you're always going to calculate the slope to figure that out. So we're going to do some practice with just finding slope now. Okay? We've been doing this a bit, so let's go ahead and put our formulas in. So one way to find it is the slope formula, y2 minus y1 over x2 minus x1. The other way, and I think some of you are really learning this now, in other words, slope is change in the y over the change in the x's, or what we've been calling delta y and delta x. The other way you can remember it is always your rise over your run. Okay? So let's go ahead. I want you to go ahead and do these. We'll do this problem together, and then I'm going to have you do these 4 independently while you hit pause, work on these 4, and then come back and check your answers with me. So let's do this one together. I'm going to stack them and do the delta y, delta x. So start with your y values. Those are 3 and 7. So from 3 to 7, you go up 4. And then from -2 to 1, you go up 3. So the slope of that line is going to be 4 over 3. Okay? Go ahead and do these 4 problems on the bottom. Hit pause now. When you're done, come back and check your answers. Okay, so for each of these problems, I did them both ways, both the delta y, delta x, and I did them using the formula. Remember, if you're using the formula, it doesn't really matter which point is your y2 and which one's your y1, which one is your x2 and which one is your x1. The biggest thing you need to remember is that those coordinates need to stay together down here. So your x coordinate goes on the bottom, y coordinate goes on the top. X coordinate goes on the bottom, y coordinate goes on the top. Okay? So for the first one, you should have gotten a slope of -3/2. Second one, a slope of 5. Third, a slope of 1/3. And fourth one, a slope of 3. Okay, make sure you have all of this completed on this page, and then we'll continue to page 1-12. Okay. So now we're going to talk about x-intercepts and y-intercepts, and I want you to think about what that word intercept means. What does an intercept mean? Okay. So think about football. Those of you who are football fans, when somebody throws a pass and somebody catches it, that's a completed catch. What if you're from the other team and you come through and you jump in the middle and you catch that? You've made an interception. So you have actually cut off the pass from where it was supposed to go. So when you're thinking about a graph, here's your graph, it's where your line is going to cut through the axes. So anything, wherever your line touches the y-axis, this would be called your y-intercept. Okay? This point over here, where your diagonal line, if it's diagonal, may be vertical, most of the time diagonal, crosses the x-axis, right here, that is going to be your x-intercept. Okay? And they have really specific rules that when you start to see these, you'll know that's a y-intercept, that's an x-intercept. Okay, so an x-intercept is where the graph or the function or the line, you can call it different things, line, crosses the x-axis. Anything that sits on the x-axis, if we just plot those points, they all have something in common. I want you to think about what that is. They don't rise above or below that x-axis. So they all have y coordinates of 0, okay? They always have y coordinates of 0, just like this. So you always set y to equal 0 to find the x value. So for all of these now, we're going to solve these individually. So what you're doing is you're substitute 0 for y and solve. So for all of these, 3x plus 2 times 0 equals 9. Well, that's easy because that just makes this go away. So 2 times 0 is just 0. So all that leaves you with is 3x equals 9. And 3 times what gives you 9? So your x-intercept would be 3. Okay? So if you were to draw that graph, this one, you would know that your first point would be on the x-axis right here. Okay? So that would be number 1. We're just going to do the x-intercepts for these lines right now. Okay? Okay, let's go on to number 2. So again, you're going to plug in 0 for y. And that's easy. What minus 0 gives you 0? Well, x just has to equal 0. We're not even going to worry about graphing these right now. We're just solely calculating the x-intercepts. So that point is 0, 0. This point is your x value is 3, and your y value is 0. Okay? Now let's do this one. So you're still, no matter where y is, you're always plugging in 0 for that if you're trying to find the x-intercept. So you'd have 0, our y value, equals 2x plus 8. In order to solve that, I need to move that 8 to the other side. When you do that, you're always going to do the opposite. So since this is positive 8, you're going to have negative 8 equals 2x. And then you just need to divide by 2. So negative 8 divided by 2 gives you negative 4. So your coordinate would be at negative 4 and 0. Okay, last one. Plug 0 in for y. 3 times 0 is nothing, so that just goes away. So x equals 9. So your your x-intercept would be 9, 0. Okay? Now y-intercepts work very similarly, except just the opposite. So it's wherever that line crosses the y-axis. Okay? Where the line, the graph, okay, crosses the y-axis. So in order to find that, you're always going to have x set equal to 0 and then solve for y. Now here's a trick. If you already have something in slope-intercept form, like this equation is, we already know that that's our slope, and this is our y-intercept. So for these, you actually can find the y-intercept without doing any math whatsoever. If you ever forget, then you're always just going to plug in 0 for x and solve. Well, 2 times 0 is 0. That goes away. So that would be y equals 8. And the coordinate of that point would be 0, 8. So it would be right here. Okay? Let's go back over here. We can go ahead and graph all of our... Everything should be sitting on this line. All of these x-intercepts. There's 4 different graphs that would happen here. They're not the same line, but all of those x-intercepts should be on the same line. -4, 0, and 9, 0. Okay? Every one of those. And they would have different lines coming off of them just depending on the graph over here. Okay? So same thing here. So our y-intercept would be 8. That means it's on the y-axis up at 8. Let's solve this. So we're still going to plug in 0 for x, so that's going to go right there. So we have 0 plus 3y equals 9. Well, that 0 just goes away, and we just have to divide by 3. So y equals 9 divided by 3 is 3. So our y-intercept for that particular function would be at 0, 3. Okay? Let's try it again. So we're going to plug in 0 for x, 0 minus y equals 0. And if we put letters to the other side, since we have numbers over here, we would add it to both sides. So we get 0 equals y. So your point there would be at 0, 0. So that is at the origin right in the middle. Okay. And last one, plug in 0 for x again, plus 2y equals 9. That goes away, because 3 times 0 is just 0. Divide by 2. Oh, Miss V, I have a fraction. What do? I can't have a fraction. Of course you can. So 9 halves, or if you reduce that, 2 goes into 9 4 times, with 1 left over, which is 1.5, or 4.5. So the coordinate for that point would be 0 and 4.5. And when you graph that point, you're just going to go up to between 4 and 5, put your dot, and you're good. Okay, we're going to be doing more practice on that in class on Thursday and Friday. So we'll do this more until you're getting really good at that. Okay, so 2 other special types of lines that we want to talk about are parallel lines and perpendicular lines. So if I have my 2 pens like this, those are parallel lines. They're never going to touch each other. They have exactly the same slope. Doesn't matter what their slope would be. If they're always parallel, they're always going to be parallel. They could be both horizontal. They could be both vertical. But those 2 lines, think of 2 streets that are parallel streets. They never have an intersection that they touch. Okay, that's a parallel line. The difference between that and a perpendicular line is that perpendicular lines do cross each other, but they cross each other in a really special way where each of these 4 corners are right angles. They are 90-degree, perfect 90-degree angles. Okay? So let's fill those in. So parallel lines have the same slope. Okay? And it depends on what the slope is for those. So what we usually say is that parallel lines equal the slope of one equals the slope of the other, and they'll call those M and M1. Sometimes it's just a label. You just need to remember that they're the same. Parallel lines never intersect. Okay? So vertical lines are parallel to each other. Horizontal lines are also parallel to each other. Remind me in class to talk to you about streets and the way they number and letter streets in big cities. Okay? So if you have 2 parallel lines, here's my 2 parallel lines. There's 2 horizontal parallel lines. Vertical parallel lines. There's 2 horizontal parallel lines, right? They can be diagonal, they can be anything. As long as they never touch, they have the same slope, they will never touch one another, they are parallel. So the big kickers is that parallel lines have the same slope. That's what you need to remember. The symbol for parallel just looks like this. It looks like two parallel lines. Okay? And you want to put it into slope-intercept form. To find the slope the easiest. Okay? To find slope for each equation of a line, and then compare. So these first two, everything's in slope-intercept form. So we're good to go on these. So I want you to go ahead and, while you're waiting for me, go ahead and write down what the slope of this equation is and the slope of that equation is. So remember, when we're doing slope-intercept form, where you find that number. Okay? Look back a couple pages in your notes if you need to. Do the same thing for number 2. So for number 1, remember that your slope is always where what's changing right before your input. So for the slope for both of these is a 4, and that does make them, they are parallel lines, okay? Because the slope is the same. For number 2, one has a slope of -3/2. The other one has a slope of 2. Those do not match. They are not parallel. Okay? Your options are parallel, not parallel, or perpendicular. Okay? That one is not parallel because their slopes do not match. Now, on number 3 and 4, those are not in slope-intercept form yet. So we need to put them in slope-intercept form, and remember that is y equals mx plus b, which means that your y is the only thing on the left-hand side and everything else is on the right-hand side. When you move these around, you're just moving things around. You want to remember to do the opposite, and you want to remember to put your x term first and then the constant. So for this, you have y minus 2 on the left-hand side, but I need that -2 to come to the other side. In order to do that, I'm going to need to add 2 to both sides. So y equals 1/2 x plus 2. For this one, that 1 is in the wrong place. I need to move him over here. So the opposite of 1 is -1. So this equation would be y equals 1/2 x minus 1. They do have the same slope at 1/2. M equals 1/2. And so they are parallel lines. Okay. Let's go ahead and do the last one. So we have a couple things we need to move around on these, but that's okay. Let's do the first one first. So everything but this y needs to move over. So 2 things I need to undo are I need to undo adding x and I need to undo multiplying by 3. So I'm going to move that x first and subtract him. So now I get 3y equals -x plus 5. And that's the same as a -1x, so let's put that 1 in there. Then y is almost by itself, but not quite. We need to divide everything by 3. So then you would get y equals -1/3 x plus 5/3. And remember, for finding out if something is parallel or perpendicular, you're only looking at the slope. This is the only thing you're looking at, is right here. The intercept is kind of irrelevant for these, okay? So let's change this one now. So we have -2x minus y equals 4. And we need to move everything but the y. So we're going to move that 2x over first. So that goes away, and you have -y equals, let's put the x in front because it helps us. Now y is almost by itself, but not quite. And we know that if there's no number in front of a variable, it's always a 1. So we're going to divide all of those by -1. And so we would get y equals -2x minus 4. And remember, the only thing that I'm looking at is the slope. If I'm trying to figure out if they are parallel or perpendicular, that's all I'm worried about. So these two, because they have different slopes, they are not parallel. Okay, let's go down to perpendicular lines. So perpendicular lines have slopes. Remember I told you that they cross at exactly a 90-degree angle? So what happens is, if they cross at exactly a 90-degree angle, then your slope stays the same, but what did it do? It flipped over the other direction, right? So what ends up happening, that if you multiply the slopes together, they always equal -1, if they are perpendicular. Okay, so they always, if multiply, they always multiply to -1. Excuse me. Vertical lines are perpendicular to horizontal lines. And we know that because a vertical line would be your y-axis, a horizontal line would be your x-axis. And we know when we cross those, we get a perfect 90-degree angle down in the middle at the origin. Okay? Perpendicular lines cross to form 90-degree angles. So when you look at any coordinate grid, this is an example of a lot of horizontal lines and a lot of vertical lines that are crossing perpendicularly, and they're creating all of these 90-degree angles. Perfect little squares in here. Okay? The symbol for perpendicular looks like an upside down T. Okay? And again, you're going to put into slope-intercept form. Slope-intercept form is really handy for these. Form to find the slope, find for each equation of a line, and then multiply. So for example, let's say you had the first slope was a 2/3, and the second slope was -3/2. You're going to multiply those two together, so 2/3 times -3/2, and see what you get. So if you, positive times a negative is always going to be a negative. This gives you 2 times 3 is 6 over 6. -6 divided by 6 equals -1. Those would be perpendicular. Okay? If I had 2/3 and -2/3, let's see what happens there. So you almost be their opposite, so they could be. No. Because look what happens. So positive times a negative is still a negative. Remember what we're trying to get to. We're trying to get to -1. So 2 times 2 is 4, and 3 times 3 is 9. So they are not perpendicular, because the only way they're perpendicular is if that comes out to -1. Okay? So the biggest trick is that your slopes for perpendicular lines will be opposite, and they have to be both reciprocal. So you flip the sign, and then you flip the fraction. So look at our 2/3 and our -1/3. We flipped it over, 2/3 went to 3/2, and it was positive, it went to negative. So you flip the reciprocal and the sign. Okay? So it's opposite and reciprocal. So let's just look at our slopes for number 1 through 4. Okay? Well, there I've got a slope of 5. Here I have a slope of -1/5. If I change 5 into a fraction, it makes it easier. So just by looking at it, I can say, okay, well, it's the reciprocal. I flipped that over, and one is positive, one is negative. Mathematically, you can check it. 5 over 1 times -1 over 5. Positive times negative is a negative. The 5's cancel out. 1 times 1 is 1. 1 times 1 is 1. So that checks off. Those are perpendicular lines. Okay. For number 2, one slope is 2. The slope of the other line is -1/2. So let's check it mathematically. And 2 times a half is 1. And then a positive times negative is negative. So we do have a negative. That is also a parallel. Those are perpendicular lines. And if we want to check that, 2 over 1 is the same thing as 2. It's the opposite, change signs, and it's the reciprocal. It flipped over. Okay? Let's see if you can go ahead and do 3 and 4 on your own and see how you do. So hit pause, see if you can try this. This one down here, you're going to need to put in the slope-intercept form. Okay, and then come back and check. Okay, so now slope of this line was 1/5. Slope of our second line was 5. So let's do it mathematically. 1/5 times 5 over 1. Oh, I get 1. Is it perpendicular? Remember that it has to equal -1. So this one is not perpendicular. Okay. The other way you know is, yes, it's the reciprocal. Yes, they're the reciprocal of one another, but they're not the opposite. They're both positive, which means they're both going in the same direction, just one's steeper than the other, but they're not perpendicular. Okay. For perpendicular, one has to be going uphill, one has to be going downhill. Okay. All right, so this one's in slope-intercept form. This one is not. The only thing I need to do is divide everything by 4. So now I get, for this one, y equals 1/4 x minus 5/4. But all I'm looking at is this 1/4 and this -4. So they're the opposite signs, so far so good. And the reciprocal of 1/4 would be 4 over 1, which is the same as that. And if I check it mathematically, then I get -1, which means that yes, that is a perpendicular line. Okay, that was our first try at video notes. Get them done, bring your questions back to me. Thanks.